All right, I'm ready whenever everyone else is ready.
Well, welcome everyone. We're glad to have you with us. I'm Dr. Louis Hassel, and we're pleased that we have guests from all around the world listening on the live feed here. If you have questions as we go along, please feel free to type those into the chat box, and we will bring those up for discussion as we go along or at the end. I'm very pleased to introduce our guest professor today, especially because I have known Dr. Tran since he was actually a medical student, and we worked together in pathology prior to his selection. And then we had the great privilege of having him here as a resident, and then welcoming him back as a faculty member in pediatric pathology with a particular interest in a variety of areas in the pediatric field, as well as soft tissue in the adult and general populace as well. So Dr. Tran, you can take it from here. You have a number of cases to share with us, and I think we look forward to what you have to say.
All right, thanks for the introduction, Dr. Hassel. So I'm a pediatric pathologist at Children's Hospital. And although I think you'll find that one recurring theme of this lecture is what happens when a pediatric pathologist tries to handle adult cases. So we'll see what happens. All right. Figure out how to use this. Share my screen now. Let me know if you guys can't hear me. Let's see. All right, can everyone see?
Yes, your screen is clear.
Okay, great. Excuse me, I have a chronic cough that's going to be bothersome throughout this lecture, but I'll try to manage. Anyway, so this first case is the patient is a 14-year-old boy, I believe, and he's got this thigh mass. It's about 3 to 4 centimeters in maximum dimension, and he's had it, I would say, for the last 4 months is what the surgeon told me. So we got the resection. It was a large mass. I sectioned it, and then I prepared. First, I prepared with cytological preparation. So I did what we call a touch prep, where we just touch the glass slide to the specimen and exfoliate some cells. And I'm a big fan of it because it preserves the cytology pretty well, and it's good for diagnosing a lot of things very, very quickly. Let's see. So here's the touch prep. We stain it with a dip quick stain. So looking at the touch prep, here we see. Can everyone see my cursor, right?
Yes.
Yes.
Okay, good. So there are a lot of ovoid cells scattered throughout the screen. So some of them are actually quite large. They're, not super large, but they're pretty big, definitely bigger than lymphocytes around it. So I interpreted these to be the neoplastic cells. I would say the majority are pretty uniform in size, but there are occasional ones that are bigger than the others, like this one right here. So I felt pretty comfortable that we got the legional cells. We had a good specimen. So then we did the frozen, which is the next step. So to that, this one is that. So on frozen, we do see a pretty cellular spindle cell proliferation, maybe low to intermediate grade in terms of cytologic features. So this could, this could be like neuronal, or it could be fibroblastic. So the differential was kind of broad at this point, but I did tell the surgeon that I was concerned for a spindle cell neoplasm of probably intermediate or malignant potential. So sometimes when I get a good touch prep, I go back and I try to get more because I like to save these. But so I went back and got another touch prep of this thing. Yeah, and so because the first touch prep was actually from a small biopsy, so then I got the whole specimen, which was the 4-centimeter specimen. So I went back and I thought I was going to get a great touch prep. So then I got, and this is what I ended up with. So this is pretty representative of the touch prep too. So what now I'm seeing here is not those ovoid lesional cells anymore, but I'm seeing a lot of just normal looking lymphoid tissue. And I thought to myself, oh, what the heck? What happened to all those spindle cells? Did I, so I guess in my, I thought maybe this could represent some sort of metastasis to the lymph node, or maybe this was maybe the lymph node, but this lymphoid tissue is the primary lesion. But, going back and looking at the frozen, I was pretty confident we did have a spindle cell proliferation. So I kind of just decided to just wait until what we got on the permanent sections and see and go from there. So this is what we got for histology the next day. So, so at low power, you can see that there is a lot of lymphoid tissue, especially around the periphery. So lots of lymphocytes and stuff. And then in the center, you kind of see a little paler area that kind of has a nodular proliferation. And if we go down higher, we actually do see that this is the spindle cell proliferation here. Let's see. Let's try to find a good area that we can focus on. Some of this didn't scan that well. Let's look. All right, so these are lesional cells. They vary from plump to spindled. You can see a mitotic figure in the middle of the screen here. They're pretty uniform in size, and then there's this dense lymphoplasmacytic infiltrate that's kind of interspersed throughout the lesion as well. So it's not only is it around the periphery, but it's also the lymphocytic infiltrate is also within this lesion. And then going back to lower power, we have some areas that have a little bit of some little cystic spaces here. Just lots of hemocysteine here focally, and then some RBCs also extravasated within the lesion as well. So that's one important thing to keep in mind about this tumor. So at this point, I kind of started off with a broad panel for spindle cell lesions that we typically always do. So fibroblastic differentiation, desmin, ended up being negative. Myogenin for skeletal muscle differentiation, that was negative. Smooth muscle actin for smooth muscle differentiation or myofibroblastic differentiation, that's also negative. S100 for like a also neuronal origin, that's also negative. And And yes, we always do a pan-keratin for spindle cell lesions because you always want to worry about keratin positive sarcoma, such as an epithelioid sarcoma. And that also was also negative. So now going back to the histology, the architecture. So yes, I did mention earlier this. On low power, it does look like a lymph node, and you also have like an expansile mass within a lymph node. So one thing to worry about is, so could this be something of primary lymphoid origin, like a follicular dendritic cell tumor? So we did staining for CD23 and CD21. So those are follicular dendritic cell markers. CD21 was a send-out test for us, and those ended up being negative. Other things that can cause expansile spindle cell-like proliferations within, or spindle cell / epithelioid cell proliferations within a lymph node would be like a histiocytic proliferation. So we also end up following that up with some histiocytic markers, CD163, CD68, and CD31, which is usually used as a vascular marker, but it's also kind of underrated as when used as a histiocytic marker because histiocytes also express CD31. So this is CD163. Looks like it's highlighting a lot of the histiocytes within the tumor, but the tumoral cells actually look negative. So, and then CD68, you can see that it's a little bit dirtier than 163. And again, excuse me. And again, it's staining, looks like mostly probably histiocytes within the lesion and not the tumor cells. And then CD31. So most of the tumor cells appear to be negative. Maybe there's some focal staining possibly, who knows? And then, so basically we, at this point, we have a lot of negative tumors, sorry, a lot of negative IHC markers. So this is kind of where you have to have some experience and you have to kind of recognize the histologic features of this tumor. And probably the most, well, before I go there, one thing that I also did was we have a spindle cell proliferation with a lot of inflammatory cells. So one thing to worry about is an inflammatory myelofibroblastic tumor. So that especially can be easily diagnosed with an ALK protein immunohistochemistry exchange. So we did that, and that ended up being so at this point we had a lot of negative IHC markers. So now we kind of have to rely a little bit more on histology to figure this case out. So the most striking thing about this is we have this lymphoid cuff around the tumor. So you kind of have to know that one tumor that tends to do this is a lesion called angiomatoid fibrous histiocytoma. And it gets its name because it has a lot of these cystic spaces that look like hemorrhagic. So hence the word angiomatoid, the suffix toid, like a vascular space. So you'll see a lot of red cells and hemosiderin within this lesion as well as cystic spaces. So along with that and the peripheral lymphocytic cuff, you definitely think about this tumor. So the one way to confirm this tumor, I guess the way to confirm this tumor is through molecular testing. So well, what I ended up doing was break apart fish test for the genes EWSR1 and also FUS. And I kind of do this commonly now. Anytime I order EWSR1, I always order FUS along with it, just because these both of these genes belong to RNA binding protein family called FET, FET, and they're pretty much kind of analogous to each other. So any tumor that has one potential can be like for example, even sarcoma, EWSR1, FLI1. So any tumor that has an EWSR1, that EWSR1 can be replaced by FUS. So a FUS FLI1 tumor could potentially be an Ewing sarcoma. So I always kind of order them together, just to save time. And then what ended up, then the results came back positive for the EWSR1 translocation. So that was also supportive of angiolymphoid fibrous histiocytoma. So this tumor, angiolymphoid fibrous histiocytoma, is a spindle cell proliferation of low malignant potential. It's a slow-growing tumor, and I reiterate that its most striking feature is probably that lymphoid cup. Like almost all of these will have a lymphoid cup around the periphery, and basically look like a lymph node on low power. The known fusions for it right now are EWSR1's CREB1 and ATF1. The clinician, when I told him about the diagnosis, and I guess they're not really familiar with these tumors, but they looked it up, and he was interested in finding the gene partner for this because I guess there are some studies that show that CREB1 tumors tend to behave more aggressively. So so we ended up sending this to a fusion panel at the Mayo Clinic, and it did find that the fusion partner was CREB1. And also one thing to keep in mind is EWSR1 and CREB1. That's also positive in a couple of other soft tissue tumors, such as clear cell sarcoma, of the GI tract, and myxoid mesenchymal tumors of the in the brain. So that's kind of like a morphologic spectrum with this fusion. So that's it for this case. And then interestingly, we also did some other IHC stains. So TLA1, which transducin-like element 1. So this is a common marker that we use to diagnose synovial sarcoma. But some studies have shown that this marker can be positive in AFH. And in this case, I would say there's some focal areas where you can see 50% of the tumor cells positive. So this is one example. And then the next stain we also did, just because we had a spindle cell proliferation, is a tyrosine receptor kinase. So nowadays, tyrosine receptor kinase is used for a lot of fibrosarcomas in pediatrics, mainly infantile fibrosarcoma. But it's oddly enough, this it ended up being diffusely positive. I'm not sure about the significance of this. The RNA fusion, the sarcoma panel, did not see any alterations in the NTRK1 or 3 genes, but for some reason, I guess this stain ended up being positive. It actually very strongly positive in these tumors. So it was this kind of interesting thing to keep in mind moving forward. We might look into it later. All right, so that's my first case, AFH. All right, I'm gonna skip down. So
Henry, before we leave this case, can I just ask, does this pan-Trk antibody and positivity in this case, would that indicate potential therapeutic target with some of the NTRK targeting reagents or drugs that are out there?
Yeah, possibly. I don't think anyone looked into that at all. Like I could not find anything about NTRK being associated with AFH. So it's something that I think someone might have to look into if you have enough cases.
Okay.
But I know TLA1 is something. Right. And next, I'm going to skip down a little bit to because I'm gonna do my easy stuff first. So parotid mass. So let's go to the slide. So here we have a mostly encapsulated tumor. You can see normal salivary gland on the outside. This was a case that was sent to me and my colleague, Dr. Yu, who's also on this teleconference. It's consultation. And excuse me, let me cough one. Real quick. Don't think I have COVID, so I always test negative, no matter how many times I test for it. All right, so back to this. So we looked at the lower power features, architecture. It's nodular, it's encapsulated, mostly encapsulated. Now let's check out some more architecture features on a little bit more higher power. We see some solid areas, we see some cystic areas. And then some more cystic areas here. So check out these cystic areas on higher power. Solid. So here's a good example in the middle here. So what we're kind of seeing is kind of like a biphasic looking neoplasm. You have a middle layer has a lumen, it has some, I guess, some mucin in the middle. And then the outer layer of these cells, we have a population of round cells that kind of have a clear cytoplasm. So having that clear cytoplasm, in thinking we're in the salivary gland, you already kind of think about myoepithelial cells. And anytime you have a myoepithelial cell proliferation, excuse me, we'll cough again. Myoepithelial cell proliferation, so it can either be like a myoepithelial cell tumor or another thing, a myoepithelial hyphen epithelial cell carcinoma. So those are two myoepithelial tumors that you can see in the salivary gland. And because of this, because it looks like these myoepithelial cells that are surrounded by, because it looks like we have all these ducts in the middle that are surrounded by myoepithelial cells. So myoepithelial cell carcinoma was our top differential, given that this is a biphasic neoplasm. And I'll be honest, I don't really see a lot of salivary gland tumors, and the actual way that I kind of figured out this diagnosis is because of another area here. So again, we have a lot of these myoepithelial type structures, and then between some of those, or within some of these areas, we see these large epithelial cells that that are interspersed throughout. So here's a good example here. So thinking, salivary glands. So what could these cells be? Could they be squamous cells? I didn't think so because you don't see really squamous junctions and like that. And then you look at the cytoplasm, it's kind of bubbly. So to me, this struck me right off the bat as sebaceous differentiation. So actually, I just Googled salivary gland tumors with sebaceous differentiation, and I came upon myoepithelial carcinoma as something that very commonly has this. And then, of course, I showed it around to people who see more salivary gland tumors than I do. And They were able to figure out that yes, these were myoepithelial cells right away. But I kind of came about the diagnosis in a more indirect way. So the staining for this, this is a P40. This stains all the myoepithelial cells. Just for example, this is a normal salivary gland next to it. This is how P40 staining should look like in a normal salivary gland. This is how it looks like in the tumor. And then this is P63, also a marker of myoepithelial differentiation. And then we have smooth muscle actin that is positive in some areas, that's in some of the tumor, and negative in some other areas of the tumor, but it does highlight the myoepithelial component pretty well. So diagnosis for this one is epithelial myoepithelial carcinoma. If you want just a myoepithelial tumor or myoepithelial carcinoma, those are usually pure myoepithelial. This is a different than that. All right, and that's it with this case. And any questions before I move on? All right. Now we can get to the good stuff. Not that better cases were also they're good too. Now stuff that kind of really puzzled us for a while. So let's look at the next case, which is a pelvic mass in a 51-year-old male. This is what I want. So we got some core biopsies. It's in the bone. So let's check it out. So first thing you kind of notice is there's a lot of necrosis, but we do have some small round cells or some malignant looking cells here with high NC ratios. Let's see. And looking at the cytologic features in some areas, the cells are occasionally looking a little bit more discohesive. They have, some of these cells have eccentric nuclei. They kind of have, I would say moderate amounts, small to moderate amounts of pink eosinophilic cytoplasm. So there is a little bit of a rhabdoid appearance to some of these. So that is pretty interesting. So again, this is an adult patient. So most common bone tumors in adults are metastatic carcinomas. So that's kind of where everyone took this at the beginning. So let's check out the IHC panel. See what happens. So the CD99, commonly historically used for Ewing sarcoma, a marker for Ewing sarcoma. And you can see in this tumor that there's some pretty nice membranous staining in some of these tumors. Pretty, moderate, strong staining. So definitely we have Ewing sarcoma on the differential. It's not specific anymore for Ewing sarcoma, but anytime you see this membranous staining, you definitely think of it. And then, however, they ended up they tested it for EWSR1, and the fish study did come back abnormal, but it was not for a translocation. It was for actually an amplification. So we had extra copies of the gene. So that by itself is not enough to diagnose Ewing sarcoma because it's not the translocation. They also ended up doing ERG, which is one potential partner of EWSR1, that's negative. Ply1 is the more common gene partner. We also have IHC for that, and that's negative. Nowadays, a lot of people are using NKX 2.2 for a surrogate marker for Ewing sarcoma, and that was negative. So right now, the histology is kind of Ewing-like in some ways, but we don't have molecular support, we don't have IHC support, so let's keep going on. But back to more basic stains, so CK18, we see that this has some really strong staining in some areas that that kind of paranuclear. So that's kind of, so when going back to on a thought of, metastatic carcinoma, this can definitely support that. Pan-cell keratin also stains very strongly and gets even more amount of cells. So could this be just, a metastatic carcinoma? And then we have more results. This is neuron-specific enolase. This is kind of sometimes used as a neuronal marker. It's not very specific, but it's sensitive for neuronal differentiation, and we have some positive cells. And since I mentioned earlier that we have rhabdoid-like features, we did an INI1, but all that is retained. So since we have positive keratin, definitely you want to think about epithelioid sarcoma or malignant rhabdoid tumor, but the INI1 being retained is not supportive of that. And then moving on to the next stain so this is the kicker, so Desmond. So we have a lot of Desmond, perinuclear Desmond staining. Could this be a carcinoma with aberrant Desmond expression? Possibly. And then myogenin is a transcription factor for skeletal muscle differentiation, and it's very commonly used for rhabdomyosarcoma. And we also have it's not diffuse, but we do have strong staining in focal areas. And this is pretty representative of that. And then the next stain is MYLD1, which is another nuclear transcription factor for skeletal muscle differentiation. And you can see here that it's diffusely positive. So in summary, we kind of have a round cell tumor in the bone that appears to be polyphenotypic. I think the most famous example of a polyphenotypic round cell tumor in pathology, you think of the desmoplastic small round cell sarcoma. However, that should have been caught by the EWSR1 fish. So we're kind of stuck here. We either have like a carcinoma with aberrant muscle differentiation or some sort of fully differentiated sarcoma with lots of polyphenotypic expression. So at this point, I kind of thought, well, let's see. Since going back to my example of the AFH, since they did an EWSR1 and that showed an abnormality, I thought, well, why not? Let's try FUS. So see what that shows. And what ended up happening, it turned out that FUS was positive for translocation. So we do have a FUS translocated tumor. So, but what is it now? So is there has someone described anything like this before? So I looked it up. And it turns out that there is indeed a rhabdomyosarcoma, a newly described variant of rhabdomyosarcoma that does have WSR1 or FUS gene rearrangements. So these two genes, they can be coupled with this gene called TFCP2. So there's this category now, TFCP2 rearranged rhabdomyosarcomas, and then the FET partners, the FET, as I mentioned earlier, either EWSR1 or FUS will be the potential partners. So these tumors are actually often seen in bones. So this presentation was in the bone, so that kind of fit. It has the epithelioid spindle. This one didn't have a spindle cell morphology, but it did have some of the epithelioid morphology. And then the IC features are actually pretty distinct. So what you're going to get is you're going to have keratin that is often either patchy positive or even strongly positive, as in this case. And then so MYLD1 and myogenin, if you don't know, so the well-known rhabdomyosarcomas that we've known for a long time are alveolar rhabdomyosarcoma and embryonal rhabdomyosarcoma. And MYLD1 and myogenin are commonly in use to differentiate the two. I mean, obviously alveolar has the FOXO1 translocation, But if you want, that confirms the diagnosis, and WAS and Abdominal will not. But if you go with the IHC, you can also use that can also be really helpful in differentiating the two tumors. So usually, alveolar rhabdos, they are very diffusely strongly positive for myelogenin, and they're also very diffusely strongly for MYD1 because they're more primitive tumors. They have more diffuse expression of this transcription factors. Whereas embryonal rhabdomyosarcomas tend to have more variable expression of MYD1 and myelogenin. So this tumor is kind of like, it's kind of in between. It's got the diffuse MYD1, but the myelogenin, however, is only focal. So I thought that was pretty interesting. So this is so new category of rhabdomyosarcoma. And I guess it also kind of shows the importance of knowing how the relationship between EWSR1 and FUS, and how both those two genes can be replaced by one another. So that's kind of how we came to the diagnosis. Right. Any questions about this one?
I'll just make a comment that I think your example here really nicely illustrates how even if you can't do the cytogenetics or the fish testing or the whatever the molecular on this, if you understand the immunohistology, you can get strong clues with that understanding. I think that's really helpful.
Yes, yes, and then Google helps too.
Yes, Dr. Google.
That's how I got to this diagnosis in the end. All right. Next case. I've got 10 minutes, so I think I'm going to skip to this. I'm going to do this one. Yes, that's this one. So this was an abdominal wall pass. So this is again a pediatric pathologist handling an adult patient. But so this one took a while to figure out. But this is a really interesting case. So we have an abdominal wall mass. So the history is that there was a mass, a periadrenal mass. This patient also had, I think, some nodules in the lung as well. So it's like, rule out adrenocortical carcinoma, rule out metastatic lung carcinoma. So my first step always, CK7, CK20, just to help differentiate, to help the two, which direction I want to take for the lineage. So it's very strongly CK7 positive, CK20 negative. I thought, actually, let's go to I totally skipped the histology, I'm sorry. So let's look at the tumor itself. So it's a pretty, if you want to give this like a pattern, I would give this probably a pleomorphic pattern, because you do have a lot of large cells, some of them even anaplastic. So this could still be, lung primary. So some poorly differentiated lung carcinomas can look this bad. Adrenocortical is also a tumor that's well known to have a lot of pleomorphism. So that those two are definitely in the differential still based on the histology here. So necrosis, and once again, huge tumor cell right here in the middle. All right, so back to the workup. So CK7 strongly positive. You can see it highlights some of these huge tumor cells as well. CK20. At this point, I was like, man, slam dunk. This is going to be a long abdomen question. Easy. Next case, PTF1, napsin, totally negative. So I'm like, wow, okay. What about is adrenal cortical still in the difference? Is it still a possibility? This is TF1, by the way. So I did an inhibin, melon pyrretin. Pyrretin, bison through SF1 and SE. In that, let's just kind of check those out. So in Pippin, we have some positive staining, but the majority of it was negative. This is probably the best that I got. And then melon looks mostly negative. I think there's a little bit of sprinkle of dye here, but mostly as negative. I don't know what the significance of that, this little sprinkle of staining is. And then the rest calretinin, steroid, SF1, synaptophysin, NC, they were all negative. So I mean, I did have the inhibin and not in adrenal cortical carcinomas. They don't always express, all the adrenal markers. So it could still be possibly. I think the only problem with that was this. It should be the keratin was positive, so we really don't have that in the adrenal cortical carcinomas. So without maybe Hayes could this be hepatocellular, the hepatocyte 1, glycogen 3, arginase, those all ended up being negative. Could it be renal? The PAX8, EFE3 for translocation associated RCC. That was negative because I thought maybe that could have some of these large tumor cells. So still stuck at nothing. So what else? I1, again, a lot like a rhabdoid tumor, but that's also now we retain. Melanoma, SOX10, SAS100 was negative. Squamous cell carcinoma, sometimes I can look more differentiated ones can be this bad looking, but that was also negative. Could be breast, GCFP15, GATA3, negative. Other pleomorphic looking malignancies, osteosarcoma. So I did a SATB2, negative. Thought about a malignant germ cell tumor. That ended up being, so I did a cell4, that's ended up negative. And then I did a mild D1 because, hey, maybe this could be another one of those TFCP fusion rhabdomyosarcomas. Maybe I got 2 in a row, but that ended up being negative. So this is some examples, arginase being negative. This is the INI1 being retained. And this was the kind of stain that finally got it. So so this is BRG1. The gene that it represents is SMARC-A4. So kind of similar to SMARC-B2 INI1. This is a related gene and protein to that. The same complex. It does the same thing. So this ended up being negative. You can see nice internal control there. So this actually ended up being a SMARC-A4 deficient thoracic tumor. So there's some debate whether or not these are de novo sarcomas or actually some variant of a differentiated primary lung carcinoma. They both behave pretty poorly. I think carcinoma does worse. The clinician asked me kind of if I could, tell the difference between the two. I think some texts they'll say that cytokeratin is something you can use to tell the difference between the two, but I think that's still debatable. But they're still trying to figure out if these two are two separate things. So I ended up just calling it SMARC-A4 deficient thoracic tumor as a whole. And I think the commission is going to end up treating it as a carcinoma because of the keratin expression. So, but after, this is kind of an example of a tumor where we kind of just threw the entire kitchen sink at the tissue, and we just, there's some I think I don't know, like some of these cells may be rhabdoid, but the premortem, I guess, was kind of striking, and so yeah, we just kind of threw everything at it and just kind of, I would say, I kind of got lucky and had some colleagues that suggested the right stain to get. So, all right, that's it for this case.
So we run into this issue in endometrial and ovarian tumors as well, where you have a very high-grade tumor and it doesn't stain with the usual markers, like, it's lost Pax8, it may have lost, other things, but just have maybe a little patchy EMA or keratin remnant and so forth. It's a very high-grade tumor. And sometimes you're seeing it in association with a lower grade, well-differentiated tumor, and so we call it dedifferentiated, but it's really just a very high-grade, undifferentiated carcinoma that has lost this SWE/SNF capability, either through INI1 or through SMARCA4 or some other component of that messaging apparatus, the SWE/SNF changes. So I think it's not unlikely that we're going to continue to see this category of tumor unfold in other areas, and we'll come to understand it a little bit more. I think you can go ahead and do one more case.
Okay, yeah, I'm gonna do this one because it's actually very interesting. So this is another tumor that we kind of received as a consult because so this was in the I guess the parietal lobe, and we received it in consultation because it had a very unusual IHC staining pattern result. So let's check it out, the morphology. So we have a lot of round cells. Some of them are even kind of rhabdoid in appearance in some areas. There's a lot of purple stuff in between. So maybe some kind of matrix. And then you look at some areas and you see actual cartilaginous differentiation. So since this was the neuropathologist in this case, it was a brain case, so they did the typical neural markers, S100, SOX10, and GFAP. So and the result was the S100, SOX10 was mostly negative. And then I think the S100 was positive in some of these cartilaginous areas, but then all of this round cell stuff was strongly GFAP positive. So this here. So this was kind of weird to them, so they kind of sent it to us in PDPath to check it out. So anytime we kind of see GFAP positive tumors that have kind of some chondroid differentiation, I think one thing that I always think of is a myoepithelial carcinoma. And it's good that it had that strong GFAP positive expression. However, the S100 was negative, and then also the keratins were also negative. So that was a little bit, so that did not support it at all. And then but maybe it's a weird one. So who knows? So I kind of kept that in the back of my mind. And then the other thing, I didn't know exactly where it was. I didn't know if it was in the brain or if it was kind of in the scalp or anything like that. So another thing I kind of thought of with this cartilaginous differentiation is mesenchymal chondrosarcoma, because you have cartilage and you have this round cell component too. So that's mesenchymal chondrosarcoma is actually presents like that. The only thing that went against it is like usually mesenchymal chondrosarcomas, they usually have an HPC vascular pattern. We don't really see that here. I actually have I posted one example down. So let me see. Let's get to the, it didn't scan super well here. So pull up on the Imperial, transfer to Pathfinder. Oh no. So yeah, I posted an example of the mesenchymal chondrosarcoma just so you can see the difference. So here's a mesenchymal chondrosarcoma. So let's see. Hopefully the resolution kicks in. Maybe. Still super pixelated for me. I think if you get a chance to look at this on your own, though, you kind of look at it at kind of an intermediate power, you will see a little bit of an HPC hemangiopericytoma-like pattern in the background. And then it does also have actual Highland-Carley's differentiation as well. But unlike the other one, this one has the HPC pattern. So, but maybe this could be a weird mesenchymal chondrosarcoma, who knows? So going back to this case, so they ended up sending this in for molecular studies, and what they ended up finding. So yeah, so I guess mesenchymal chondrosarcoma and myopathic carcinoma, they both have molecular findings, and for myopathic carcinoma, that's the EWSR1 or FUS gene rearrangement. And then mesenchymal chondrosarcoma is the NOCA1 translocation. So since I sent that in, I was hoping that maybe the gene panel will find it. But what they ended up finding was this tumor. Let me type it out. Mouthful. So it's this gene translocation is called ATXN1 nut. So this, so nut, we know that gene is seen in a lot of nut rearranged carcinomas and some sarcomas as well. And then ATX1. So what they did was they did some RNA like profiling with this case. So ATXN1, it turns out that this profile is very similar to a soft tissue Ewing-like sarcoma that we recently described maybe like 5-6 years ago, but we kind of know about it pretty well now. It's called sick ducts carcinoma. So it's kind of thought that this tumor is in that same family now, because based on the RNA profile, kind of like how FUS and EWSR1 are kind of in the same family. They're kind of thinking about including this into like the sick family of tumors. And for this particular case, these tumors, they're very strongly positive for GFAP. They have mixochondroid differentiation, and how they relate to these sick ducts sarcomas. That's still being looked into right now, based on the RNA profiling sequence patterns. So that's this case. Any questions?
Well, we're pushing the boundary here. That's really exciting to sort of unravel a complex tumor like this and begin to ponder what some of the how the molecular phenotype and so forth will drive potential treatments and all those sorts of things. Any comments? I don't see anything in our chat function. Does anybody have any questions that they'd like to bring up? A lot of thank yous. So Henry, when you're searching on a kind of an unknown case like this, what kind of questions do you pose to Dr. Google?
Oh man, you kind of have to. Yeah, I was thinking about making like some sort of video about this, because I think Google has helped me a lot in pathology, but you have to be very mean, you have to be very fluent in your pathology terms. So,
Yeah, maybe that's a good topic for another video. I agree.
yeah,
How to use Google effectively as a pathologist.
right. Because a lot of times I'll go straight to the answer for something that I don't even know about. And I learned a lot.
Yeah.
So yeah. But yeah, that's something I kind of been trying to think about the last month actually, like how actually effective Google is.
Well, very good. Thank you, Henry, for your help with these interesting and challenging cases. We posted the link for the slides so that people can come back and review them. And we will look forward to any questions people have. Please feel free to send them off, and we'll try to triage those and get them to you if you're viewing this later on. But otherwise, till next time, thanks so much for joining us on Sign Out with the Professor.
Thank
Thank you guys.